Well, hey ho there, neighbors. What? What's wrong with Mr. Krause? Has he gone crazy? No, that's from like a 1980s TV show. First of all, I want to apologize for getting this out so late. Normally I get this stuff done at 5 o'clock in the morning. It's now 11. At like 5 o'clock in the morning, I was actually sleeping because I didn't sleep at all because I've been sick. Ugh, nasty flu. I cannot seem to shake this flu. I don't know about your school, but this year, 2017, the nasty flu is going around, and I got it. And I've been sick for 3 weeks now. So whatever. Stop complaining. Nobody wants to listen to it. My name is Mr. Krause, but for the next hour or so, you can call me Mr. Key. I will be doing in this video part 1 through 12. Now, if you're here because you already took the test and you're just checking to see what you got, great. Hit the subscribe button. Hopefully I helped you out. If you are here to just copy down my answers, please do me a favor, press that red X up here in the corner. You see, this red X up here in the corner. Press that red X, get rid of this. Stop cheating. You're not going to get anything from cheating. You have to try these problems on your own. You have to. I saw some kids take this test. No perseverance. In fact, that's going to be my next. Now, I'm going to say perseverance, I think, every day for the rest of this year. Perseverance, the ability to get through something that seems insurmountable. That's the Krause definition. The ability to get through something that seems insurmountable. Can you figure out a way to do it? Now, while you go through this video, I'm going to show you how to do it the right way. I might show you how to do it a different way, and then I'm going to show you hopefully how to use the calculator or some of your other tools to quote-unquote cheat to get through some of these problems. But even cheating is going to require you to have some mathematical knowledge. Yes, kids, it's big boy time, big girl time. We have to work, okay? So, without further ado, let me get to the next page and let's get started on this puppy. I will do the very best to try to explain all these problems. One of these problems don't think is actually accurate, but we'll see. So let's get started. So, relative to the graph of y equals sine of x. Now, this is a straightforward transformation question. Straightforward, no difference, okay? This has an amplitude of 3. This one has an amplitude of 3. This one has a period of 2 pi. This one has a period of 2 pi. However, we added this thing. This is the new thing that's added. And if you take f of x and you transform it to f of x plus, let's just say 3, this is a horizontal shift. It is a shift left or right, and you have to remember that it's backwards. Now, if I did, so in this case, we would be moving left 3 because it is positive. And normally positive would go right, but in this case, we're going to go left. Now, if I had this, then it wouldn't be left 3, it would be right 3. Now, if I take the function f of x, and I transform it and I create f of x and I put the plus 3 on the outside, that's up 3. If I get rid of the plus and make it a minus, that's down 3. So this is a straightforward left 3 movement. The only thing I did was I added on the inside of those parentheses, and that's a transformation to the left 3. All right, I'm not going to lie. I missed this question. I misread this question. I thought it was much easier than it was. It had a bunch of things going on that I missed. So let's see if I can get this correct. A rabbit population doubles every 4 weeks. Kind of important. There are currently 5, so that is my initial. That's my initial amount of rabbits in a restricted area. If t represents the time in weeks, how long will it take? How many rabbits will there be in 98 days? So here's the problem. They give it to you in 98 days. You need to convert it to weeks. But remember, it's every 4 weeks, not every week. So the actual equation is pretty simple. You're going to say the population is equal to my initial amount, 5. It is a doubling. That means it's an exponential function. So it's doubling. So we're going to put a 2 as a base. Now, my exponent, I thought, would just be t. But it's not t. It's t divided by 4. because it's every 4 weeks. Now, what is t? Well, t is equal to 98 days. But we were not given doubling information about days. We were giving doubling information about weeks. So the first thing you need to do is convert this into weeks by dividing by 7. So you come over to your calculator, you do 98 divided by 7, you get 14, and it's 14 weeks. But again, it only doubles every 4 weeks. So that's why we divided by 4. So now I'm going to take my calculator. I'm going to stow this 14 into t. And I'm going to type my function in. 5 parenthesis 2 parenthesis raised control division to t. I could have just put 14 in. I don't know why. I didn't need to really store it. 14 or t divided by 4, which is 14 divided by 4, and I get 56.56. So about how many rabbits will there be? About 56. There's the answer to that question. This is a straightforward, very easy question. First thing we're going to do is take out the m, because that was a GCF, and we get m to the 4th plus m cubed minus 6. This should be m squared. I apologize. We took out an m. Now, some of you don't like the factor when this is not a 2. So let's get rid of that. Make it a 2. Let's just make that as there. So let's just factor this. Okay, it's m. Now, what multiplies to 6 that add negative 6 that adds up to 1? Oh, that's positive 3 and negative 2. Positive 3 times negative 2 is negative 6, and they also add up to 1. But that's not the original problem. The original problem was this. So we got to put these squareds back. And so then that makes this my answer. Now, I did say I was going to show you some cheats, right? Here's one where we can cheat. Now, it's time-consuming to cheat, quite honestly. I always pick a weird number, 3.45. Doesn't matter what number you pick. Just don't pick 102. I pick something weird, and I'm going to store this in m. Now, my original problem, I'm going to read it off my page here, so I don't have to keep going back and forth, was m to the 5th. Got to get out of exponent mode if you're going to do this right. Plus m cubed minus 6m. And I'll press enter. 509,123. Now I'm going to put in my answer. My answer was m parenthesis m squared plus 3 parenthesis m squared minus 2. Did I get it all right? Do I get the same answer? Oops. Doesn't like implied multiplication. Whatever. So implied multiplication is probably, it doesn't like that I didn't put a times here, and also I don't think it likes that I didn't put a times here. I think the calculator should be smart enough. There it is. Boom, done. Now, could I have gotten this answer? This answer would also be correct, but this is not factored completely. So if you did this, both of these would come out right. So as a smart kid, you say, oh, I got to factor it completely. Let me pick the one that's more complete. Okay, kids, this couldn't have been an easier question. Like, really, really, really easy. You need to know, at least from trig, that cosine squared of who cares plus sine squared of who cares is equal to 1, so long as these things match. I don't care if you have a smiley face here. Cosine squared of a smiley face plus cosine squared of the exact same smiley face is equal to 1. So the answer is 32. That's it. Cosine squared plus sine squared equals. But let's say you forgot that fact. Come on now, perseverance. Being able to get past something that looks insurmountable, but it's really not, and there is a way around it. So how about we take 32, store it into m? I think they used m. Did they use m? I think whoever wrote this test must have been named Michael or something, or they liked Mr. or Miss. And then I do. Now the hard part about this one is putting it in right. You have to do it like this. Trig, and hopefully your teachers taught you this stuff. 32, and then squared, plus, parenthesis, trig, cosine, sorry. Probably going to be doing that a lot today. 32. Oh, I could have just used m. Sorry about that. I stored m. Oops. Let's do squared. And guess what? Oh, it's 1. Done. Problem's over with. Let's keep going. That one's easy. Straightforward. So what is the solution set of this? So we have this function here. Now, quite honestly, when I first read this, I thought, hey, they want me to tell me what the equation of this parabola is, which is really quite easy. It's just x minus 2 squared. How did I know that? Well, it bounced off. It only had one root. And when it only has one root, it's kind of like when you do completing the square. You create a perfect square trinomial. Now, does it have any dilation? Well, if I go to the left one, I go up 1. If I go to the right one, I go up 1. So no dilation. I can check it again. If I go to the left 2, I go up 4. And if I go to the right 2, I go up 4. So I could have just done it that way. Figured out what that is, and I'm going to show you that other method in a minute. But simply, let's just graph this thing. This is like an algebra question. Everybody should have gotten this one right. My y-intercept is 2, and my go up 3 over 1. Not there yet. Up 3, 1, 2, 3 over 1. Not there yet. I missed something. Up 3, 1, 2, 3 over 1. Sorry, kids. Mr. Krause needs to learn to count. I knew something was off. Let's try this again, sisters. Down here at -2. Up 3. How about we go up 3? 1, 2, 3 over 1. Wait, let me do this in different colors so you can actually see what the heck I'm doing. So there's 1. Up 3 over 1. Oh, there it is. There's one of our answers. 1, 1. There it is. We're done. Problem's over with. 1, 1. There it is. Now, that's straightforward. Coming over to your calculator and actually doing it on your calculator is a little bit more treacherous. This one you would have had to actually know that should have been x minus 2. I'm honest with you. You should know this. That's this parabola. There it is. Hit tab. You type in 3x minus 2. You hit enter. And then you go menu, analyze graph, intersection, click, click. There's 1, 1. And you can't see the other one. It's up here somewhere. You go into menu, analyze graph, intersection, click, click. There's 616. But that would have been that you had to understand about this parabola being x minus 2 squared. But hopefully by now you understand when you bounce off like this, that's going to be a pair of parentheses squared. Okay? Which statement about statistical analysis is, now this is the part that this New York State loves to do. The answer, the word is false. Which one of these is false? Experiments can suggest patterns and relationships in data. Well, you create an experiment, what you're looking for is something repeatedly happening. Because if you can show, hey, this continues to happen, then I can make an assumption or I can make a prediction in the future. And so you're looking for patterns. You're looking for things. So yes. So this can't be the right answer. Experiments can determine cause and effects. Sure. I create an experiment that says if I put baby oil on the floor and watch people walk by, my guess is they're going to slip. Cause and effect. I watch kids walk down, they hit the baby oil, they fall. I go and I probably get arrested for being an idiot. But it is cause and effect. And of course, if you create an experiment, you're also looking for cause and effect. And you're looking for those effects to be patterns or maybe to generate a pattern so you can see the relationship of the data. Sure. Observational studies can determine cause and effect. Observational studies can determine. I think that's the right answer. But let me go look at the next one. Observationals can study patterns and relationships in data. Sure, you can sit there and watch people on a hot day walk by a drinking fountain and say, okay, I think that they're going to drink more often than not. And they say, okay, yeah, there's a pattern. You know, they start drinking more. The hotter the temperature, I can observe the heat, and I can observe the fact that I didn't set up the experiment. I just sat there and watched. But you cannot determine cause and effect unless you are setting up an experiment, and that experiment has to be set up very, very carefully. So there's our answer, choice 3. By the way, if you haven't taken the time to hit the subscribe button, please do so. Us YouTubers live of having more subscribers. The more subscribers we have, the more popular we become on Google, and the more people can find us, and you help me out. So please, do me a favor. If I'm helping you or if I've helped you in any way, please do me a favor, hit the subscribe button. It helps me out. I say thank you now, and you'll help out future kids that are kind of looking for things. And it's easier to find my videos if I am a more popular YouTuber. And that's all I'm really trying to get, is to get out at the population. All right. This was a particularly easy question to cheat on. Hard question to do mathematically. So if this was to occur as a part 2 question, I would be remiss if I don't show you how to do this the right way. So let's tackle this thing. We're going to tackle it piece by piece. M squared m to the 1/3 to the 1/2 power, to the negative 1/2 power. And it's that negative we're going to take care of first. If you remember correctly, if I have 1/2 to the negative 1, that's simply equal to 2 over 1 to the positive 1. A negative exponent will cause the thing to be reciprocal. If you simply just have 2 to the negative 1, well, that's equivalent to 1 over 2 to the positive 1. Remember, this was 2 over 1. So it's just taking the reciprocal. So that negative exponent really means let's take the reciprocal of this thing. So that's what we're going to do first. M to the 1/3 over m squared. Okay. Now we're going to raise it to the 1/2 power. So when you raise an exponent to an exponent, you have to multiply those exponents. So I'm going to multiply these two together, and I'm going to multiply these two together because I got to raise both of these. So this becomes m to the 1/6. That's what 1/3 times 1/2 is, all over m to the 1. But I could write 1 if I want there, because this is 2 times 1/2 is just 1. So what happens when we have exponents and we're dividing? We subtract the exponents. So this is really m to the 1/6 over m to the 6 over 6. Well, who has more? The denominator does, clearly. So what I'm going to do is I'm going to get rid of this 1/6, and I'm going to get rid of 1/6 here. It leaves me 5/6. So my answer is 1 over m to the 5/6. Now, that's not one of the answers, but it should show you that it's got to be one of those two, because it is, in fact, a fraction. Now, you need to remember that if it's in the denominator, it is a root. Roots, like if you think about a plant, roots are in the ground, right? So when you're dealing with a rational exponent, the roots are in the ground. So the denominator would be a root because it's on the bottom. And then when you say power up, like you want your Mario Brothers to power up or whatever, powers are in the numerator. So this really is 1 over. It's a 6th root of m to the 5th. Now, that's a crap load of work for a multiple choice question. Now, what have I done? I wouldn't have done that for sure. I would have gone like this. I would have been like, dude, seriously? I'm just going to say laundry's done. 3.47 control var x. Maybe it'll be quiet in here now. Excuse me. And then I'm going to just type in the answer, type in the problem. Let's see. Now, you got to be careful. Control division. You got to type it in exactly right. Oh, I used x. I should have used m. So I'm going to change to x. X squared over x to the 1/3. X raised to the... Oops, why did I do that? Yeah, I don't like the fact. Let me just do this. 3.47 control var m. I want to use m anyway. So let's try this again. Parentheses, control division. I know why I did that. M squared over m raised to the control division. That's what I'm looking for. And it's 1/3, right? 1/3. 1 over 3. Oh, this calculator is a lot nicer. It's not, you're not able to use this one on I think this is actually going to give us the answer. I forgot the negative. Oh, good. It gave us a decimal. Okay, so this is what I have, and it gave us a decimal. Now I want to type in my answer. My answer was control division 1 over, oops. Let's try this again. 1 over the 5th root, or the 6th root of m raised to the 5th. That was my answer. Is it the same? 0.3545, 0.3545. I could have simply just used the calculator and do it, but now it's a pain in the neck. But this one was a pain in the neck either way. You weren't getting around it being a pain in the neck. Coffee. Subscribe. Let's go. All right, what is the inverse of the function? Well, this one's not bad. First thing we do when we do inverse is we interchange the x and y. Okay, so I get x equals log base 3 of y. Well, now you need to remember the change of base, right? It's all about that base, about that base, about that base. There's the base right there. Base, so we're going to change it. Now, I don't really like the way this one looks, so I'm going to just write equals x over here. It makes it easier for me. So it's 3, and then these two change places. To change it from a log to an exponential function, those change place. So 3 to the x is equal to y. And there's my answer. Excuse me, 3 to the x equals y. These two change places. Normally, see how it's 3 to the y here? Well, I just conform it. Now, I think you could have easily done this one on your calculator. This one's not a problem to do on your calculator. You have to remember one fact, and we'll talk about that when we get there. And that is, let's graph this thing. I don't like these. So let's just do this. So we're going to graph log. Now it doesn't have a base, right? Nope. Oh, it's base 3. Log base 3 of x. There it is. And you should know that. All log functions pretty much look the same way. And the inverse of a log function, by the way, the inverse of a log function is an exponential function. So, you shouldn't have gotten this. The inverse of a log function is not that. So it had to be one of these. And this is not an exponential function. That's a cubic function. So it had to be one of these two. This one we really can't graph. So the only one we can graph is this one. So I want to check my answer. So I'm going to come over there. I'm going to graph 3 to the x. Tab 3 raised to the x. And I'm going to hit tab, and I'm going to graph the line y equals x. Now, why the line y equals x? Oops, tab. Why the line y equals x? Well, because inverses are reflections over the line y equals x. Do those look like reflections? Does the blue curve and the red curve looks like the reflections over this? Absolutely, and there's the answer. All right, kids. We're going to come to this question. Now, I'm going to be totally 100% honest with you. Statistics is not my strongest area of expertise. However, after I did pick the right answer, but after working with my statistics teachers in my building, I think I've concluded that the answer that they give is not correct. But I am going to tell you the answer that they chose. Let me just triple check. This is question 9. Yep. All right, so let's get through it, and I'm going to explain what's going on. Gabriel performed an experiment to see if planting 13 tomato plants, let me grab my highlighter, 13 tomato plants in black plastic mulch. What is black plastic mulch? Leads to larger tomatoes, 13 plants that are planted without mulch. He observed that the average weight of the tomatoes from tomato plants grown in black plastic mulch was 5 ounces greater than those from the plants planted without mulch. To determine if the observed difference is statistically significant, now this is, I think, the important part, statistically significant, he re-randomized, I don't understand that, the tomato groups 100 times, and this is what he came up with. So let's see. We want the statistical differences. So let's go to where 5 is. 5 would be right here in the middle. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3. Somewhere around here. Maybe this. So those are like right in the middle. That would be 5, right? So this 5 represents the difference of what I thought was going to happen. Let's say I wanted to say that mu1 is equal to mu2. And this is the fact that mu1 is less than mu2. Well, what I want to do, one of these is correct. One of these is going to be my null hypothesis, and this is my alternative hypothesis. But what I want to do, and this is the way I kind of went through this one and rethought this problem out. I said, okay, here is a difference of 5. Normally, here's a difference of 0. And clearly, it's a little bit weighted more this way. So I wanted to find out how many dots there are. So I counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. Probably around 37. So about 37% of the tested, what are these things? Tomato plants had a difference greater than 5. 37%. And we want to know if that's statistically significant. Or did it happen just by chance? And that's where I think they messed up. If I'm talking about a statistical significance, then a statistical significance in my mind, what I'm looking for is something that is so rare, or that is rare enough that you're like, okay, I can say that shouldn't have happened by chance. It should have actually happened. So, if you pour water on plants and you don't pour water on plants, and you see that you have a huge growth for the plants on water and an average or a slightly average growth on the ones without water, you'd say, hey, and let's say it's like 95% of them are higher. Remember, we're looking for statistical significance. We're looking for something way out here on the tail that said, hey, you have no option but to say that was a statistical significance. Like it is so far up to the top of this graph, you say, okay, I would expect to see that difference of 5 95% or more times. But we only saw that 37% of them were higher, which means that 63% of them were lower than that 5. So is 5 really statistically significant? Not at all. It's not statistically at all. Which is why my stats teacher and I came to agree that the answer should be number 1. There is no effect observed between these two groups. Why? Because that could have happened by random chance. And if you use the study or the theory of large numbers, if I'd done this 1,000 times or 1,000,000 times, maybe it would turn out to be, 0. It would be perfect. It would be perfectly symmetrical. But what New York State said was because there were 37% that were above this, that there was some effect observed, but it really isn't due to the random assignment of the plants in the group. And so this is the answer that they chose. Me reading through this problem, I choose choice 1. Them reading through the problem, they chose choice 2. I quite honestly don't think it's a very well-worded question, but there it is. That's my rationale for my choice. Alrighty, kiddies, let's keep going. If P of x equals A times B to the x and R of x equals C times D to the x, then P of x times R of x is equal to. Quite honestly, I'm going to show you both ways. This problem could have been done by stowing numbers, right? But let's look and see what we got. P of x is A times B to the x. And so this is P of x. And we're going to multiply it times R of x. Oops, excuse me. R of x we'll put up here. And that is C times D to the x. Well, this is all multiplication, so I can change the order any way I want, right? Because isn't 5 times 8 the same as 8 times 5? Right, or is 2 times 5 times 8 the same as 8 times 5 times 2? Absolutely. It makes no difference what order I choose. So I'm going to reorder this. I'm going to put the things that don't have the x's together. So A times C times B to the x times D to the x. Now what? Now what are we going to do? You got a base, and you got a base, and you got an exponent. Now this goes back to something I said earlier on this particular problem. Do you remember when we had an exponent? We had exponents raised to exponents. Now in this case the exponents were the same, but I can simply just, if I have one exponent, I can raise each of those to that exponent. So if I come back over here and I say, okay, wait a second, I can just say, hey, this is really B times D to the x. And I'll put the AC out front. Now why is that true? Well, because when you, remember these exponents are 1. When you raise an exponent to an exponent, you multiply the exponent. So this would, if I did this, I would say, oh, this is B to the 1 times x times D to the 1 times x. And get that way. So the answer is choice C. Now, I could have done it this way. This is going to be a royal pain in the neck, but do you have perseverance? Can you take your time and do it? Let me get a clear screen here. I'm going to take 1.2 and I'm going to stow it into A. Again, I'm not picking normal numbers, 2.3. I'm going to stow it into B. Again, notice how much a pain in the neck this is. And 5.2, control var, what do I got? C. And then I got one more, 8.1, control var D. Now, the original problem was, let's figure out what P of x is. Because all I asked for is P of x times D of x. So let me figure out what P of x is. P of x is A times B to the x. Oh, I got to make up a number for x too. How about we make x 2.5? Stow x. Again, this is a pain in the neck problem. So P of x is equal to A times B to the x. A times B raised to the x. Some obnoxious number, there it is. That's P of x. I'm going to store that, well, I'll just leave that. And then I'm going to do B of x, or C, R of x, which is C times D to the x. C times D raised to the x. And I get some obnoxious number. And then I got to multiply those two. This times this. There it is. Okay, so what answer did I came up with? I came up with A times C times parenthesis B times D parenthesis raised to the x. Now I'm hoping it's 9,347 point blah blah blah. There it is. So yeah, that took me like 3 minutes to do. Actually didn't, but it took a little while to do, but it's doable. All right, let's go. All right, again, problem that could have been done by cheating. We're not going to do this one by cheating. We're going to do it the right way, and then I'm going to do it the very, very fast cheating way. Or, in other words, I'm going to check my answer. So I can take out a GCF. A 3 comes out of all these. Is a 6? No, because this is not even. So I can take a 3 out, just to have smaller numbers. And this is 6x squared minus 8x plus 81 is 27, 28, 29. This must be 29. Equals 0. So now I'm going to do the quadratic formula on this. I can't do completing the square, so I'm going to do quadratic formula. A is 6. B is negative 8. C is 29. And I always, if you've ever seen my videos, do D, which is really the discriminant, B squared minus 4AC. So B squared is 64. Minus 4 times 6 times 29. That I will type into my calculator. So 64 minus 4 times 6 times 29. Negative 600, what? Is that right? Negative 632? Okay, so I'll use my quadratic formula. Let me get it in a different color. Hopefully this is above my head. X equals negative B, 8. Over 2 times 6 plus or minus the square root of negative 632 over 2 times 6, which is 12. So I need an I in my answer. Any of these things not have I? Okay, they all have I, which is good. All right, so 632. Wonder if there's a perfect square that goes into 630. Well, I wonder if 158 goes in. Ah, 4 times. 100 goes in 4 times. So if I take the square root of negative 632, that's really equal to negative 4 times 158. Now, where did I get the 158? They all seem to have 158 in them, so I use that. I didn't know that for sure. This is 2i. Okay, so now I'm done. X equals 8 over 12 is 3/4. Excuse me, 2/3. Plus or minus 2i square roots of 158 over 12, but that reduces to 1/6. So 2/3 plus or minus I square roots of 58 over 6. This is the answer right here. Now, what I would have done on this problem, that's the answer. That's the right answer. We'll leave it as that. All that work could have been subsidized by just doing this. Now, first of all, the formula is negative b over 2a. In this case, that would be, if I just go from this, that would be 24 negative b, which would be 24 over 2 times 18, which if you put that in your calculator is 2/3. So that means it had to be one of these two. It couldn't be these. They didn't use negative b. So it had to be one of these two. So here's what I would have done. Quite honestly, I would have just done this. Control division, 2/3, plus 1/6, control division, 1 over 6, time, oh, is it I? Let's do times. Doesn't like that. I times the square root of 158. Yeah, pain in the neck. Store it in X. Stupid answer. What do I care? 18x squared minus 24x plus 87. Now, if this is right, it should be 0. You have to remember, kids, that this, see this thing right here, times 10 to the negative 11, that's 0, and times 10 to the negative, that's 0 as well. This is one really messed up way of saying, oh yeah, that's 0. Now, if you didn't believe me and you thought it was this one, so I could redo it. I could go up here and say, okay, maybe that's not the right answer. Maybe it's this one. You know, I don't know what that is, but let me do 6i. The only difference between these two, I think, is this one's 6i, right? And then I go up here. All right, that's 102,000, and this is 0. No more i's, but this is 102,000. That's not 0. So that was I guess that was kind of tricky. All right, last problem. When g of x equals this and h of x equals this are graphed on the same set of axes, which best coordinate? All right, this is going to take me a second. Let me come back. All right, all I'm going to do is graph this thing. This is a test on whether or not you can use your graphing calculator appropriately. And can you round appropriately? I believe there's some rounding issues on this one, which makes it a little bit nasty. So we'll go to our graphing calculator, and we're going to do 2 over x plus 2. Control division, 2 over x plus 2. Graph it. There it is. Shouldn't come as any surprise. And then we're going to do the log of that. So tab, control, log. It didn't have a base, right? The base is 10, so I don't need to put anything there. Of x plus 1, x plus 1, plus 3. Enter. So you'll see the only place they hit is here, which is like negative 1, 2. So let's go find negative 1, 2. So clearly it is not these. But negative 1, that's really close to negative 1. That's really close to negative 1. Look at this. The only difference is this is 1.8 and this is 1.9. So I need to use my calculator tool in order to find out what is that point of intersection. Click, click, and there it is. It's negative 0.92. Well, we knew it was negative 0.9, but look at this. It's 1.86. 1.86, which rounds to 1.9. So I apologize if you got that one wrong. There's the right answer. All right. That ends part one, first half of part one. Hit the subscribe button for me, please, and hopefully hit the thumbs up. Hopefully it did okay. All right, I'll be back to do the next one.